So this is going to be our first introduction into volumes of revolution. So the first one I'm going to talk about is the disk method, and we are going to do a vertical rotation and a horizontal rotation. So the first thing I want to do is I'm going to start with the line y equals 6 minus 3x, and we're going to rotate this around the x-axis. So we're going to take this area right here, and we're going to rotate it around the x-axis. So let's think about what shape that's going to make when we're all done. So let me bring down a little bit more here. So you can imagine, right, it will be creating this kind of triangular solid, like a round pyramid, a cone. Hey, there we go, a cone. So let's think about how we would find the volume of this, keeping in mind our calculus background. Right? So just like we were finding area between two curves, we're going to kind of start with that. So I'm going to go ahead and draw a rectangle, a representative rectangle, that we're going to rotate about the x-axis. So we'll take this rectangle and then we're going to rotate it around. So if we want to know the total volume of this cone that we're going to create, one way that we can do it is we can look at the volume created by one of these rectangles rotating and then add up all of the rectangles that would be. So that's what we're going to do. So let's think about what shape this one rectangle rotating is going to make. And you will please, please, please forgive my drawing. I really, really do suck at it. All right, so one of those rectangles is going to make a disc. So it's just right, it's going to do a circle with a little bit of a thickness. So to find the volume of this disc, right, it's the area of the circle times the thickness. Okay, so what's the area of the circle? So area of the circle is pi r squared. And now the thickness. So this is why it's really important to draw those rectangles, because it tells you what the thickness is. This is going back to finding the area between two curves, right? So it's the little chunk of x is our thickness, that delta x, but then, right, we squish it down eventually, and we're going to make it a dx because we're going to make it super small. Okay, so we kind of have a general idea of what one of those volumes is going to be. Now r. So here's what I want you to do for now and most of the rest of this time together. R for us is going to be distance from the axis of rotation. That's how I want you to think about it, because pretty soon we're not going to be sitting on an axis. We're going to move away. We'll rotate around a different line, a different axis, not just the x-axis. So we'll have a little space. So R is going to stand for the distance from the axis of rotation. So right now, if I look at this picture, right here is my, well, somewhere in there is my R value. So R corresponds, in this case, to the height of this rectangle, and the height of the rectangle is the Y value. So Y is equal to 6 minus 3x. Since I know I have a dx here, I want to take the right-hand version of that, right? I want the y value, but I want to put in the 6 minus 3x. So the volume of one of those disks is going to be pi times r, but r is now being played by 6 minus 3x squared dx. So that's one of those disks. And now we just need to add them all up. So the way we add all of these up in calculus, right, is we integrate. And then I need my limits of integration. So I have dx's, right, that's how I have chunks. So then I need to look at where x goes from, where it starts. So here it starts from 0. And where it ends. So it ends where my line intersects the x-axis. So that's when y is 0. So that looks like that would be x equals 2. Okay. And now we have something to integrate. So for this one, right, pi is a constant. You can move it out. You could either do a u sub, or I think I'm just going to expand that. So I'm going to go ahead and hop over here because I've got the space. So I'm really going to integrate pi 0 to 2, 36 minus, what is that, 18 18 times 2, also 36x plus 9x squared dx, and then term by term, 36x. I don't know why I always use brackets when I do antiderivatives, but I do. Doesn't matter. Parentheses are awesome. But you want to make sure the pi is going to multiply everybody. 36x squared over 2 plus 9x cubed over 3. Right? No plus c because I have limits of integration. And then we'll just plug in. I'll probably tidy on my way. So pi times 36 times 2 minus 18 times 2 squared plus 3 times 2 cubed. And then it's minus 0, right, because everybody has the x, so polynomials, right, the zeros are our friends. Again, I'm not going to trust myself this morning with arithmetic, so here we go. I grab my calculator. Pi times, okay, I'll do a little bit, 72, 10 times 4, oh, minus 72. Okay, so that's gone. So then I really just have that last one, which is, what, 3 times 8. So that looks like 24 pi is the volume we get if we rotate this line around the x-axis to make a cone. Now, what do you think is going to happen if we take that same line and rotate it about the y-axis? Oh my gosh, Angela. So here we go. Y equals 6 minus 3x, same line, but now we're going to spin it around the y-axis. So if we're going to do discs, we're going to learn how to do another way in a minute, but discs, we draw our rectangle. So for discs, the rectangle is perpendicular to the axis of rotation. Okay. So, right, if I'm rotating around the y-axis, I drew my rectangle perpendicular. So imagine all of those rectangles swooping around, and you can see, right, we're going to make another cone. Oh, geez. So, right, it should be the same on both sides. So we're going to make this vertical cone this time. So now I want to find the volume of our vertical cone. So, same idea. What is going to be, right, so I need the volume of a disc. And so there's one of those discs. Here's the y-axis coming through the middle. So I need the r, distance from the axis of rotation. So in this case, right, we're x away. So my r value in this case is going to be x. My thickness, look how it's going, right? It's a little chunk of y. So my thickness is going to be dy. So I need to write, it's for discs, it's pi r squared times the thickness. So pi out front, r squared. R is the x value this time, right? So I need x squared, and then my thickness is dy. So I'm kind of showing you now how how you can set it up without, right, knowing a bunch of stuff in advance. You can just go, okay, what is it supposed to be this time? It's supposed to be x, but my thickness is dy. How can I fix that? Because I'm only integrating dy if this is a y. Right? So I need to get x in terms of y. So I'm going to come up here to my equation, and I'm going to solve that for x. So we all have our own ways of doing that. I need my x's to be positive. So x is equal to 6 minus y all over 3. That's what's going to go in here for my x. So let's see if I can fit this into my little space here. So I've got my pi. Oh, I don't have my limits yet. I need to square this guy. So I've got 6 minus y over 3 squared dy. I'm going to bring the 3 squared out front because that's a constant. So now I have pi over 9. And then I have, can I do this on the side? I have 6 minus y squared still left in here. Okay, I won't. 6 minus y squared dy. Let's grab those limits. So where does y start and where does y stop? Okay, so my rectangles, the smallest y value I have is down here, right? Y equals 0. And then I stop when I get to the top of the line. So, right, the y-intercept, which is 6. So I'm going to go ahead and expand my binomial. So pi ninths, integrating 0 to 6, 36 minus 12y plus y squared dy. Term by term. Pi ninths multiplying everybody. 36y minus 12y squared over 2 plus y cubed over 3. Sorry about the crampedness. I think I can squeeze it in right here. Okay, stay with me. That 3's not there. Okay, so now we evaluate between 0 and 6. So pi ninths. Here goes the 6. 36 times 6 minus 6 times 6 squared. Oh, look, those go away again. And then plus 6 cubed over 3. And then again, my lower limit was 0, and since these all have y's and they're polynomials, that's a minus 0. So these guys are going to cancel because they're opposite. So I have pi ninths times 216 over 3. And I should do that in my head, and here I am not. So 216 divided by 27 is 8. So 8 pi. Notice they're different. Same line, but we get a different volume depending on which axis we rotate it around. Okay, so let's wrap up. Disk method, volume of revolution. So your rectangle is perpendicular to the axis of rotation. You write the volume for one of the disks, pi r squared dx. Figure out what r is. Oh, I'm sorry, times the thickness. So either dx or dy, depending on which axis you're going around. So it looked like around the x-axis was a dx, and around the y-axis was a dy. And then it is just integrating pi r squared times the thickness.